surface marks the first CCS project in the UK at the moment. It's the first well that's going to be completed to allow us to inject CO2 into the subsurface.
Everyone is quite excited, especially now when all the real hardware is on land.
There's a lot of new technology going in here with the fibre optics, which is relatively new for us, and it's fairly complex.
Finally getting to the point where we're starting to see things actually happening.
Come up to Halberton here in Montrose to basically make up the completion assemblies that are required for the CCS well on the H1 platform.
In order to inject CO2 and to have a proper monitoring of it, we will need to run new tools one by one down to 2 kilometers.
The completion itself basically acts as a conduit to allow us to safely deliver the CO2 from the surface down to the reservoir.
By pre-plumbing some of the assemblies and preparing the assemblies in the way we're doing, we've taken some of the risk out of running the completion.
All this requires some integration to make sure they all work properly before we ship it offshore. For this completion, we have implemented different systems from different manufacturers. One of the reasons is to understand how we operate this, because it's new technology, and the other reason is to qualify them for future operations.
So Halberton is the main completion provider for Perenco Le Mans. We're providing our SP tubing retrievable safety valve, our OPSIS downhole pressure and temperature gauges, our MFT feed-through production packers, sliding side doors and accessories.
We have perforated joints in there which allow us to actually inject the CO2. We then have completion packers that give us isolation across zones.
To allow pressure to build up inside certain parts of the reservoir that we want.
Weatherford is providing the optical pressure and temperature sensor. We are also teaming up with Selexa to integrate our sensors with their distributed measurement capability, all within a single optical cable.
The trick with CO2 is that when it goes to liquid phase, it's going to be a very cold liquid. We must ensure that the equipment will not fail under these conditions.
We are taking an optical sensor that has been proven in extreme environments of 300 degrees Celsius, and we are now pushing it to the opposite end of the spectrum to reach the lower end limits, reaching up to minus 30 degrees Celsius.
The equipment makeups consist of torquing on handling pup joints onto the assemblies, function and pressure testing all of the equipment, drifting and taking measurements.
So things like pressure testing, we'll make sure that we pressure test it to the correct value.
By the end of the week, all the equipment should be ready. We'll gather them and then backload them to the jetty in order to be ready to send them offshore.
It's great to see the hardware that we have designed or modeled to be in front of us today.
There's a lot of eyes and visibility on these first projects as we start to look at, well, what happens when we inject CO2 into the subsurface.
And we recognise this is not only an important milestone for Perenco, but for the industry in UK as a whole.
It means that we are progressing in the right direction for enabling CCS as a viable solution for the energy transition sector.
Everything is made up and we can walk away and know that we're ready to run the completion offshore.